Hello, once again. This is Mr. Lowry, and I'm here to do another video in relationship to our topic, polynomial functions. So, in today, what I want to do is I want to go ahead and talk about 2b. So, 2b, this particular problem or this particular target, it really focused on our ability to write these particular functions. And so there's a couple places I want to make sure I highlight. And so I want to take care of that at this time. So where this starts off is being able to write functions. And so in doing so, one example is if we are given zeros. So an example would be if we are given the instructions to write a polynomial function, but we're given a set of zeros. So let's say we're told that x is equal to 3, 4, 4/5, and 0. So to be able to write this particular function, if you recall, what we end up doing is taking each of these separate zeros and getting all of it set equal to 0. So getting everything away from being alone and bringing everything over to the x part. So 4x equaling 3, we would end up subtracting 3 on both sides. So we get the expression of x minus 3. For x equals 4, we would subtract 4 on both sides. So we end up with x minus 4. Now, for x equals 4/5, we can do this a couple ways, but the most simplistic way is just subtracting 4/5 on both sides. So we get x minus 4 over 5. And when we look at x equaling 0, we can keep it like this and just have x. Now, another way we can write the same answer is x minus 3 times x minus 4, still times x minus 4/5, but then we would have x minus 0 if we wanted to honor that same pattern for the last 0. Now, let's talk about if we have some multiplicity, because that can show up here, and we have to honor being able to write the function that would include the multiplicity. So our goal is still to write the function, but this time we're going to have x equals 3, 4 with a multiplicity of 2. We're still going to keep 4/5, and we're also going to have 0, but that's going to have a multiplicity of 3. Now, when you compare this to what we just did on the last slide or last scene, we're going to keep the same attention to detail and do the same action. We still have x equals 3, x equals 4, x equaling 4/5, and we also have x equals 0. So once again, when we solve these and we move things over, like subtract 3 on both sides, we still get x minus 3. For this one, we will still subtract 4 on both sides, so that will give us x minus 4. This one, like we said, we can still just subtract 4/5 on both sides, and we would still end up with x minus 4/5. And for the last one, we can keep it as x or x minus 0. What changes, though, is now we look at our multiplicity, and that tells us which 0 will get which exponent. Because right now they all have an exponent of 1. But the 4 is said to have a multiplicity of 2. So that means that x equaling 4 happens twice. So that means for our factor, we're going to put a 2 as its exponent to recognize the multiplicity of 2 at x minus 4. So with 0, it has a multiplicity of 3. So we're going to place a 3 as the exponent on x minus 0. Now, once again, this is just talking about that particular zero. Therefore, we're going to go ahead and just make sure that zero has that multiplicity. But we're done. We've done our writing our function. We have our answer. We're good to go. There's nothing else to be worried about for this particular problem. So now let's talk about writing these functions, but let's actually be given a different set of information. More or less, we are going to be given characteristics here. So here's what I'm referring to. We are still writing a function. We're still writing a polynomial. But this time we're told that our degree is 5. We're told that our vertical intercept is y equals negative 20. And we're told that as x gets smaller, y gets larger. So our goal is to write a polynomial function that has that feature. Now, here's my recommendation to you. When you're given these features written in this way, which are totally different than the first two examples that I've shown you, you want to write this in standard form. So don't use parentheses, kind of go straight to the source of what it's going to look like. Here's what I mean. So the first thing we're given is that the degree is 5. So create your x and give it to the 5th power. That will take care of your degree part for you. When it comes to the vertical intercept being negative 20, go ahead and place negative 20 at the end. Because if you put 0 in for x, you're guaranteed to have negative 20. That's going to take care of your vertical intercept. Now, the part where you have to really be mindful of what's being said is this statement here. As x gets smaller, y gets larger. Remember, this is degree 5, which is an odd number. So either you're going to have one go down and one go up, or vice versa. What makes the difference is the sign on the leading coefficient, whether it's positive or negative. Now, we read this as x gets smaller. So we're talking about the left side of the graph. Y gets larger. That means it's going to go up. So we're going to want our leading coefficients to be negative. So before you get to that x to the 5th, you want to put a negative sign. This is the answer we want to roll with. Now, there's other variations you can have with this, but these are the parts that has to at least be there and parts that you don't override. So an example of what I'm trying to say is another answer you could have written for this would have been negative 4x to the 5th plus 9x to the 2nd minus 20. I still have my degree 5 because that's my biggest exponent. I still have my vertical intercept be negative 20 because that's the only number without an x. And my leading coefficient still is a negative. You can have a number here if you want to, but that number has to be negative. So this is another example that would be a suitable answer for this problem. Okay. So hopefully I've answered your questions in relationship to what 2B is going to refer to. The only other portion that may pop up for 2B is going to be naming some of your features in relationship to the graph or the equation. Pertaining, particularly when we talk about vertical intercept, which I address in this portion here. If you ever want to know what the vertical intercept is, when you have the standard form, it will always be that number that doesn't have an x to it. If you so happen to have a problem where there's no number without an x, then it's 0. That'll be your placeholder. Other than that, any other questions, I believe you are prepared for it and you did an excellent job previously. So that being said, I'm going to go ahead and conclude the video at this particular time. I hope you have a great day. I hope you do well on 2B, and I hope to see you soon. Have a great rest of your day.